Yo, what's up, calculus students? How's it going? Good to see you. We miss you still. I am going to put together a video of easy multiple choice AP questions that are easy to get right, but a lot of students get them wrong. Your goal, I'm going to try to make this video as quick as possible, is see if you can get them right. Pause the video, see if you can get the question right. I'll tell you the most common mistakes, easy mistakes made, and the right answers and how they're easy to get. Starting with Unit 1. Y equals 5 is a horizontal asymptote to the graph. Well, a lot of people forget what horizontal asymptote mean. We talk about horizontal tangents. So we're thinking about like tangents that equal 0, or we're thinking like tangents who are slope are 5. A lot of us probably forgot that horizontal asymptotes are when we are looking at x approaches infinity of a function. And when you plug in infinity, we got different rules. We got things that are insignificant versus things that are significant. And it's the idea of what do you get when you plug in infinity? Well, it's all about relative growths, faster's over slower, slower over faster, same over same. This has a horizontal asymptote of 5. That is the answer. None of the other ones, even if you took the derivatives would not help you with this question. Another horizontal asymptote question from Unit 1 is a limit at negative infinity. A lot of people, they're like, oh, I get horizontal asymptotes. I get about insignificant. And they're like, oh, this one wins. This one loses. This one wins. This one loses. They either answer 2/3 or negative 2/3. That's wrong. They answer, oh, this 2 to the x is actually slower growing than the 3 to the x, slower over faster. You could think about slower over faster, and you could answer that your terms are getting closer to 0. So you'd answer 0. And you'd also get that wrong because, and this is a huge mistake made, as you approach negative infinity, exponential functions are no growth functions. So actually, you should have crossed off when you're plugging in negative infinity to the x and 3 to the x, and your answer to this question is 3/5. Did you get that right? Who knows? Next, Unit 2, derivative rules questions. Very easy question. Here's h. You're asked for h prime of 0. Most students that get this wrong say, oh, that's easy. H prime is just f prime over g prime. And they're like, okay, f prime is 4 and g prime is pi. And they're like, there's the answer, 4 over pi. You're wrong. It's a quotient. You have to use the quotient rule. So take the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. And you got to figure out all the values. F prime of 0 is 4. G of 0 is 2. So I got an 8. I see that 8 right there. And then minus G prime is pi times F is 3. That's 3 pi. 8 minus 3 pi. There's the answer. Cool. So we're good with that question. Then we get to the next question. We see what is the derivative of h here. And you're like, cool, yeah, I'm going to remember my rules this time. So I know that h prime is f prime times g plus g prime times f. And you're like, okay, f prime of 1, we're going to look right here, is negative 3. G of 1 is 3. G prime of 1 is negative 2. F of 1 is 5. And you're like, okay, I got negative 9. Then I got minus 10. I got negative 19. Hooray! You're wrong. Wrong, 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 wrong. This is not a product. This is a chain. This is an O and an I. It's an F and a G. This is easy to do. This is easy to get right. This is an easy question to get right. So many people get it wrong. H prime is F prime of G of X times G prime of X. We need to do H prime of 1. H prime of 1 is G of 1, which is 3. We need F prime of 3, which is 7. We need G prime of 1, which is negative 2. And the answer is negative 14. How'd you do on that? Unit 3. All right, here we go. F has a local max. Obviously, the max is right here, negative 1. No, you're wrong. This is not F. This is F prime. This is the derivative. We know F has a max if F goes up and goes down. That's when F prime changes sign from positive to negative. I hope none of my students say negative 1 is the answer. They say 1 is the answer. The other question a lot of people get wrong, how many relative extrema does G have? Okay, extrema, that's when G has a max or a min. We got to look at the signs of G prime. So you look at G prime and you're like 8x cubed plus 24 x squared. And you're like, oh, cool, set that equal to 0. And we set that equal to 0. And we have 8x squared times x minus plus 6. And you're like, cool, x equals 0, x equals negative 6. I have 2. You're wrong. Why are you wrong? Because if you did a sign analysis, which I'll do up here because my face is probably in the way. If you did a sign analysis around negative 6 and 0, you would see that g prime does not change sign at 0 because of its multiplicity. It will not change signs at 0. It'll just change signs at negative 6. This is the same thing for points of inflection. Make sure you test your signs. Easy question to get right. A lot of students get it wrong. Unit 4, inverse derivatives. Do you remember how to do inverse derivatives? Usually this question shows up later on the multiple choice and students are like, this is foreign to me. I have no idea what's going on. But you have to recognize that this is the indication that we're talking about inverses. And if you remember inverses, f has a point a, b. And the slope, when the x coordinate is a, is c. G is the inverse of f. We'll have the point b, a. And the derivative of g at the x coordinate b is going to be the reciprocal. This will be db over dA. This will be dA over dB. What's the relationships? The reciprocals of each other. If you want to find g prime of 7, you are going to look at when f's y coordinate is 7. F's y coordinate of 7. Here we're talking about h, sorry. H's y coordinate of 7 is right here. That is when the x coordinate is 3. And when the x coordinate is 3, the slope is 5, which means this slope is 1/5. 1/5 is the answer. Easy question to get right. Very quick question, but a lot of students get that wrong. Unit 5, implicit derivatives related rates. The first question is making sure you don't forget about the chain rule, the product rule with x and y, and distributing the negative. If you want to leave the negative out, great. Derivative of the first times second plus the derivative of the second, the derivative of y's or dy dx times x. Make sure this negative gets distributed into that parenthesis. I'm not going to do the rest of this problem, but that is the biggest mistake that students make, is forgetting the product rule, forgetting to distribute negatives. Then for related rates, you see this question right here. You got v of x is x cubed, and a lot of us are like, cool, v prime is 3x squared. But we're not really reading things correctly. We're not really realizing is like respect to time, centimeters per minute. And we're not just taking the derivative of this normally. We're taking the derivative with respect to t. Too many students forget dx dt. They would probably just like take 2 and plug it in and get 12 and circle 12. And they're wrong. Here we have dv dt is 40. This is dv dt. We are asked what is dx dt. So we get 40 equals 12 dx dt. And that answer is 5. How'd you do on that? Unit 6, antiderivatives. Too many of us think that a negative power, you use logs. You are wrong. The power rule works for every power. Do you remember the power rule? Let's start with something like x cubed. We add 1 multiplied by the reciprocal to undo stuff. So x to the negative second, we would add 1 and multiply by the reciprocal. Don't forget your plus c's. This is the answer. Also remember, if you are taking the antiderivative of something like cosine 2x, don't forget it's the sine of 2x. Remember, going backwards, forwards with antiderivatives, and undo the derivative, you need a 1/2. Okay, this is different than the derivative of cos 2x, which would be negative sine 2x times 2. So don't forget about antiderivatives of negative powers. Unit 7. A lot of times students forget plus c's when going backwards. Here's a question where you have a calculator. It's a calculator question, and you're asked to find a position. Well, first things first, a lot of students try to antiderive this to find a position function. They're like, I could do that. You can't. You can't take the antiderivative of 4 over t cubed plus 1. Go ahead and try. It's not going to work. So since you have a calculator, what you should be thinking about is how you can accumulate, how you could graph your velocity and you can accumulate your velocity. So a lot of students will do that, and they'll take the integral of it and they'll be like, okay, 0.352, that's my answer. And they go ahead and circle 0.352, and they're wrong. Why? You have to remember, which is the fundamental theorem of calculus, that The accumulation of a derivative just tells you how much f goes up or goes down. This 0.352 is just how much my position increases. We need to know that my position started at a position of 1. We need to add that. If we are going backwards, we would subtract that integral. So don't forget about that. If you can't take the antiderivative, or if you just have a calculator, accumulate the derivative. You'll tell how much we increase or decrease, but we won't get a position. We'll just know how much the position changes. So if we have f of, or p of 1, p of 2 is 1, we add how much displacement we have to get p of 4, which is 1.353. Great. Unit 8. These questions, so many students get wrong. They're so easy to get right. Here's a function. What is f prime of 2? Here's a function. What's f prime of 2? A lot of students try to do a lot of crazy things, but we need to understand. What if we talked about just, say, g? Cool. What is equivalent form of this? Well, we would take the antiderivative of g and plug in x, and we take the antiderivative of g and plug in 0. That's the fundamental theorem of calculus. What if we were to take the derivative of this? Well, the derivative of this is just regular g. So taking the derivative of the accumulation function appears to just be regular g. F prime, this big F prime, would just be this. That's it. There's nothing crazy to do here. It's your understanding of this guy up here, which helps you understand this, which means you want to plug in 2. Great. You get the square root of 9, which is 3. There's nothing crazy here. A lot of people try to take the derivative of this, and they're like a 1/2 and t cubed plus 1 to the negative 1/2. And it's like, no, don't do that. Now we come to this one, and a lot of people are like, oh, cool. So my probably function, f prime, is probably just this with 2x plugged in. And they plug in 2, and they get the square root of 16 minus 4, which is the square root of 12, and they circle the square root of 12, and they're wrong. Why? Well, you got to remember, what happens if this was 2x? Well, that would be big G of 2x minus big G of 0. The derivative of big G of 2x is not regular G of 2x. It's regular G of 2x times 2. So the fact that this is a function means when I take the derivative, I have to use the chain rule. There's an outside and an inside. I have this extra 2. So it turns out the derivative of this accumulation function is just a regular function with 2x plugged in, but then times 2. So we got the square root of 2x squared minus 2x, but then times 2. And that's why the answer is E. So many students get that wrong, but look how quick these questions are to get right. Unit 9. This question is the biggest question that students get wrong so quickly. It is so easy to get right. Students are like, okay, from 0 to 5 3 plus 2x, that's easy. I got 0 to 3, 3 to 5. So I know 0 to 5 is going to be 10. So I'm going to multiply that by 2 to get 20. I'm going to add 3. I'm going to get 23. And I'm wrong. Why? Because we can split up this integral because of the addition into 2 different integrals. And we realize really quickly that the integral of 3 is either 3x with 5 plugged in and 3x with 0 plugged in, or it is a rectangle of area, height 3 with 5. This is actually 15. The 2 ways to get it, you can discuss, and then this is 20. My answer is 35. So many different students get that wrong. It is so easy to get right. This question, a lot of students have no idea what to do. They're probably just like, oh, I guess I got to divide by 2 to get this. That's wrong. They're probably thinking, oh, isn't this the one where we change our numbers? And they're like, okay, so I'm going to change my numbers and I get that. Anyways, it's a use substitution problem where if we change things and we kind of like decompose, instead of having a composition, we'll kind of work on undoing the decomposition. We have our inside of our composition, whose derivative we want to undo. So we get du over 2. Well, if u is equal to 2x and these are x's, and I kind of undo the whole composition, we get that the integral changes to 24 and 12. We get f of u du, but we have this du over 2, which means I need to multiply everything by 2 so I can take out that 2, get rid of that 2, and I'll have 20. So we end up with this answer. It's a very easy question to get right. A lot of students get it wrong. Then finally, unit 10, our last type of question. We got this graph, we got the x-axis, we got a vertical line, x equals 10. We're trying to find the volume generated when we rotate this around the y-axis. First mistake made is we don't know which axis is the right axis. The second mistake made is we forget the idea of having cylinders and cylinders with holes in it. We would need a pi big R squared times h, and then we would subtract the small cylinder, which is a pi smaller r squared times h. We realize if this was flat, that h is a very small y distance. We realize that the formula for a cylinder with a hole in it could be looked at as pi big R squared minus small r squared h. So a lot of people think it's going to be right minus left squared, or top minus bottom squared. A lot of people will do something like this. Now, like, we're revolving it, so we see these are x distances. We should have it's x equals y squared plus 1. Cool. And you'll think, oh, okay, right is x equals 10, left is x equals y squared plus 1. And they put that as the answer, and this is wrong, 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 because it's outer radius is squared. We kind of don't want this blue guy here. We want the two cylinders. One has an outer radius of 10, so I'm going to have 10 squared, and then the red one has the radius of 1 plus y squared. We want that, which ends up being that. That's my big R squared minus my small r squared. Okay, so as you're going into your first practice multiple choice test, seniors at home, which you might want to do, this weekend or before this weekend, definitely like latest you're doing it is on Monday. Keep in mind all of these different questions that are easy to get right, but so many students get them wrong. And remember, it's a calculus test. It's an AP calculus test. If a question seems too easy, most likely you're not doing it the right way. All right. I'll be back next on Friday for another helpful reminder video. Hope you appreciated this. Hopefully, it doesn't intimidate you. Just telling you to remember these key types of questions, and you'll be fine. We miss you out there. Hope you're having fun. Peace.